Hello, good morning. My name is Mark. Welcome to my channel. Today we're going to look at these transformers here. It's a 300 watt transformer made by Jameco, JAMECO.com. It only costs about $50, I believe, from what I remember. Now, over here, this is going to be part one of 2 videos. And I've got 3 of these transformers hooked up. And a step down transformer, 10-to-1 step down. And there's 4 branches. Here's my diagram I drew last year. And AB is one straight through branch. CD, E, F, and GH are the 3 transformers here. I only got 3 transformers hooked up out of 7 that I need. Yeah, 7, but there's 8 branches altogether. Now this should save 90% electricity as I calculate, but maybe it won't. Maybe it'll only save 50%. Now, this transformer is connected to the cord, which plugs into this duplex receptacle, and it puts out about 125 volts rather than 120 volts. So it causes a step-down transformer to put out about 15 volts instead of 12 volts. So I only need about 8 power branches instead of 10. So what happens is there's 15 volts going down each parallel branch, and they're isolated by these transformers so they don't short out with one another. So 15 times 4 equals 60 volts. So I need 2 hands to operate my meter, so you have to just trust that it measures 60 volts. And it's running this LED light bulb here at 60 volts. So now I'll plug it in, and I'll show you. But here's all the terminal strips, bus strips, because there's going to be a lot of connections. And I got to be careful that nothing shorts out here, nothing touches. So I'll plug it in, and the light will come on. There's the light on at 60 volts. It's a 10.5 watt LED bulb. So now what I gotta do is measure the current and show you this clamp-on current meter. Sticking in this open wire here. Now it's measuring 0.08 amps. That's as small as it measures. Well, 0.07, yeah, it goes to 0.08 maximum. That's the output going to this lamp. Now over here, I measure what's coming out of the wall. There it is. And it's measuring 0.06. 0.07. I'm staying on 0.06 mostly. So really close to 0.07. but I'm going to use 0.06. So what I do now is use the proportion formula to calculate what percentage of current I'm saving. And what that is 0.06 over 0.08 equals x over 100, and you cross multiply. So that equals 6 divided by 0.08 equals x, which equals 75. So that's 75%. It only requires 75% current coming out of the wall that the lamp needs. So that means it's saving 25% on the electricity so far. So when I hook up 4 more of these transformers, I have them down here in the boxes, 4 more there. I'm hoping it'll save 50% or more. Hopefully more would be really nice. If it only saves 50%, it's not really worth it, because my other diagram 8 will only use 3 transformers. But I was really hoping to step down transformer, because it converts voltage into current when it steps down the voltage. It provides more current to the load. There's an example. You want to look at these here. Formula there, proportion formula, proving that it could save 90%. I'll draw this later on at digikey.ca. Scheme it for a better diagram. Okay, I guess that's enough. See you later when I do part 2.